Every advanced tech of the Roman Empire explained. These doors haven't moved in nearly 2,000 years, but when they were built, they opened by themselves, with no motor, no electricity, and no human hands. Just fire. That's not the only thing the Romans built that we still struggle to fully explain today. A concrete that repairs its own cracks. A machine that should have started the Industrial Revolution 1,700 years early. A factory feeding an entire city before the concept of a factory even had a name. In this video, we're going through every piece of advanced technology the Roman Empire ever created, and explaining exactly how each one worked, from automated temple doors to a vending machine that dispensed wine in the 1st century. This is Roman engineering, fully explained. Chapter 1. Automated temple doors. Picture a Roman temple, sometime in the 1st century. A priest walks up to the entrance, pauses before 2 enormous bronze doors, and lights a small fire on an altar beside the steps. He doesn't touch the doors. He doesn't need to. Slowly, silently, they swing open on their own. This wasn't theatre. It wasn't illusion. It was a working mechanical system designed by Hero of Alexandria, an engineer so far ahead of his time, it's genuinely difficult to categorize him. Here's how it worked. Beneath the altar, a sealed container held both water and air. When the fire was lit above it, the heat caused the air inside to expand. That expanding air pushed down on the water, forcing it through a hidden pipe into a second container hanging below the floor. As that second container filled with water, it grew heavier, and its weight pulled down on a pair of ropes. Those ropes were wrapped around 2 vertical poles connected directly to the door hinges. The weight turned the poles. The poles turned the hinges. The doors opened. When the fire went out, the air cooled, pressure dropped, and the water was pulled back into the original container through negative pressure. The doors closed themselves, and the system reset. No human involvement, no electricity, just fire and gravity working together in perfect sequence. It worked every single time. But Hero wasn't done. He had an even bigger idea, one that the Romans chose to ignore, and the world paid the price for it for almost 1,700 years. Chapter 2. Steam Engine. The Aeolipile, Rome's missed industrial revolution. In the 1st century AD, Hero of Alexandria built a functioning steam engine. Let that settle for a moment. A steam engine. In the 1st century, he called it the Aeolipile. It consisted of a hollow metal sphere mounted on 2 pivoting tubes above a sealed kettle. When a fire was lit beneath the kettle, the water inside boiled. Steam rose up through the tubes and into the sphere. With nowhere else to go, the steam escaped through 2 small nozzles on opposite sides of the sphere, and the force of that escaping steam caused the sphere to spin. It worked. A rotational engine driven entirely by steam, more than 1,600 years before James Watt patented his version in 1769. The principle Hero had discovered, that steam under pressure can generate mechanical motion, is the exact same principle that powered the Industrial Revolution, launched the age of steam-powered factories, and reshaped the entire modern world. The Romans saw it as a novelty, an interesting toy for philosophers to discuss. No one seriously considered attaching it to a wheel or a pump or a grain mill, and so it sat, admired and unused, until the idea was reinvented from scratch in 1712. It's one of the most extraordinary missed opportunities in the history of human civilization. But while the steam engine was ignored, another Roman invention was quietly doing something that scientists couldn't even explain, until 2023. Chapter 3. Self-healing concrete and the Pantheon. Modern concrete is remarkable. It is also fragile. Many structures built in the 20th century have already crumbled. Bridges crack, foundations shift, Buildings require constant maintenance to stay standing. Roman concrete has been standing for 2,000 years. For a long time, historians assumed this was simply because Roman structures were massive and overbuilt. But MIT researchers suspected something else was happening, and in 2023, they finally confirmed it. Roman concrete does not just resist damage, it heals itself. Roman engineers combined volcanic ash, volcanic rock, seawater, and quicklime, a mixture already unusual by ancient standards. But the method was just as important as the materials. They mixed it at extremely high temperatures, a process called hot mixing. This left small, unincorporated chunks of lime scattered throughout the finished concrete. Under normal conditions, those chunks would look like defects, poor quality control, sloppy work. They were not. When cracks formed and moisture seeped in, those lime chunks dissolved and triggered a chemical reaction, creating a calcium-saturated solution that flowed directly into the crack and hardened. The concrete was literally repairing itself from the inside. When MIT recreated the Roman formula and deliberately damaged samples, the cracks healed completely within just 2 weeks after exposure to water. The implications of this went far beyond walls and floors. Self-healing concrete meant Roman architects could attempt structures that no one had ever built before. Wider spans, thinner walls, more open interiors. Which brings us to the Pantheon. Built around 125 AD, the Pantheon has the largest unreinforced concrete dome ever constructed. It measures 43.3 meters across, and that record has never been broken in nearly 1,900 years. Not by medieval builders, not by Renaissance architects, not by anyone at any point in history using concrete without internal steel reinforcement. Modern structural engineers still study it, not just as a historical curiosity, but because they genuinely want to understand how it is still standing. The secret is partly in the dome's design. It becomes progressively lighter near the top, with heavier aggregate at the base and lighter pumice near the oculus. But it is also in the concrete itself, still intact, still strong, still healing. If Roman concrete had been adopted by the modern construction industry, we might be building very differently today. But not every Roman breakthrough was about permanence. Some were about pure scale. And nothing demonstrates Roman industrial ambition better than what archaeologists uncovered in the south of France. Sponsor break, insert here, approximately 60% through place store or sponsor mention. Chapter 4, Barbegal Mill Complex, Barbegal, Rome's first factory. The word factory didn't exist in Roman times. The concept didn't exist either, at least that's what historians assumed, until excavations near Arles in southern France revealed something that changed the picture entirely. The Barbegal Mill Complex was built in the 2nd century AD. It had 16 water wheels, arranged in 2 parallel rows descending a hillside, powered by water channeled from 2 separate aqueducts above. Each wheel drove a pair of millstones inside a dedicated building. Grain was fed in at the top, flour came out at the bottom. The wheels worked in a continuous sequence, one feeding into the next, creating an unbroken production chain down the entire slope. The complex could produce an estimated 28 tons of flour every single day. That is enough to feed 80,000 people. It took approximately 30 workers to operate the whole site. That is nearly 900 kilograms of flour per worker per day, using nothing but flowing water and stone. This was industrial-scale food production, a production line, a facility designed not just to grind grain but to do it at a volume no single mill could ever achieve. All of this existed roughly 1,500 years before the Industrial Revolution officially introduced the factory to the world. Archaeologists still are not entirely sure how it was managed logistically, how the grain arrived, how the flour was distributed, who maintained the water channels. But the physical structure is clear enough. Rome had figured out mass production, and powering all of it, the mills, the cities, the aqueducts themselves, required a system of water infrastructure so vast it was the backbone of the entire empire. Chapter 5: Aqueducts. The aqueducts. At its peak, the city of Rome had 11 major aqueducts. Together they delivered over 1 million cubic meters of fresh water into the city every single day. That's more water per person than many modern cities supply today. The Roman aqueduct system stretched over 500 kilometers around the city of Rome alone, and that's just Rome. Across the entire empire, engineers built aqueducts in Spain, North Africa, Turkey, and throughout Western Europe. Some of those structures are still standing. What makes the aqueducts remarkable isn't just the scale, it's the precision. Aqueducts relied entirely on gravity. There were no pumps, no motors, no mechanical pressure systems. Water moved because the channel was built on a perfectly calculated slope, gradual enough to maintain flow without creating damaging current, and steep enough to keep the water moving over distances of 50, 80, even 100 kilometers. The average gradient of a Roman aqueduct was roughly 1 in 4,800. That means for every 4,800 meters of channel, the elevation dropped by just 1 meter, across dozens of kilometers, through mountains and valleys, over bridges and through tunnels. Roman engineers maintained that slope with instruments no more advanced than a water level and a plumb line. They also built the aqueduct channels using the same self-healing volcanic concrete we discussed earlier, which is part of why so many sections survive intact today. The water didn't just flow into the city, it was distributed through a tiered system, first to public fountains and baths, then to businesses, and finally, as a luxury, to private homes. Access to running water was a symbol of status in Roman society, but the fountains meant that even the poorest residents of Rome had access to clean, flowing water within walking distance. It was urban infrastructure at a level that most of the world wouldn't see again for more than 1,000 years. But after all of that, all the engineering, all the concrete, all the water and scale, the invention that might best capture what made Rome truly extraordinary is also one of the smallest. And you've probably walked past something like it today without giving it a second thought. Chapter 6: Vending Machine. The world's first vending machine. This is a coin. Drop it into a slot at the top of a clay jar, and wine pours out automatically, stops on its own, and dispenses exactly the right amount every time. Hero of Alexandria built this in the 1st century AD. It is, by every reasonable definition, the world's first vending machine. Here's the mechanism. The coin drops through a slot and lands on a small pan inside the jar. That pan is connected to a lever, balanced by a counterweight on the other side. The weight of the coin tips the lever, which pulls open a valve at the base of the jar. Wine flows out. As the coin slides off the pan, which it does naturally because the pan is angled, the counterweight pulls the lever back to its original position, and the valve closes. The flow stops. No electricity, no springs, no gears, just a coin, a lever, and gravity. It was used in Egyptian temples to dispense holy water to worshippers who paid an offering. Simple, self-contained, and completely automated. The concept then disappeared. It was not seriously revisited until a British inventor built a coin-operated postage stamp dispenser in 1883, nearly 1,800 years later. The first vending machine for food appeared shortly after. Today, the global vending machine industry is worth over $50 billion a year. Hero had the idea first. The Romans just were not ready for it. The Romans built an empire that lasted centuries, and the engineering behind it is a large part of why. But what's striking isn't just that these technologies existed, it's how close they came to changing everything. a steam engine that could have started the Industrial Revolution in 100 AD, concrete that heals itself, only recently explained by modern science, a factory producing 28 tons of flour a day before the concept of a factory was invented. They weren't just builders, they were problem solvers, working at the edge of what was possible with the materials and knowledge they had, and sometimes well beyond it. If you enjoyed this, follow the channel for more content like this.